Hello everyone. So today we're gonna talk about building AI agents in Kotlin using Koog framework. My name is Vadim, and I'm a technical lead of Koog.
And my name is Andrei Bragin, and I'm a senior developer on the Koog team.
Yeah, Andrei, who is my co-host today, is actually one of the first team members of the Koog team. And could you maybe share briefly about your background?
Yeah, sure. Before joining Koog, I was doing some data engineering and background work, and background work. Yeah, background workers and backend services, and I was working at JetBrains about 5 years by now. Yeah, and you, Vadim?
Yeah, so I'm around 8 years with JetBrains. Started my career as a developer of Kotlin. I worked in Kotlin IDE, then Kotlin libraries. Then it was a part of Ktor team. Then I was also a backend developer myself, doing some backend for Kadana, which is a code analysis tool on the cloud. And after that, after a few AI initiatives that I was doing, I started doing Koog. And here we are. So let's probably jump straight to the point. Today is basically the first of currently 2 episodes that we have planned, and it's going to be more of a basic introduction into building AI agents with Koog, and the next one will be more advanced. So the plan for today. At the beginning, we're going to talk a little bit about the overall vision of Koog and high-level plans around the framework and ecosystem. Then we also cover some architecture of building AI agents using Koog framework. After that, stay with us. We're going to do some live coding and hands-on all together. And finally, I hope we will have time. We will have a Q&A session. So let's start. Koog. Koog is the framework for building AI agents in Kotlin. And it was open sourced during the Kotlin Conf on the May 22nd, right? So I remember, since then, we gained quite a lot of attention from the community, which is cool. Andrei, do you remember how many stars did we get during the first week?
Yeah, if I remember correctly, it was like 800 stars during the first week after the Kotlin Conf, and the whole team was really happy. Our work gained lots of attention, and it keeps growing naturally, right?
Yeah, absolutely. And one of the cool things is that recently we got attention of Docker. So they posted this nice blog post from their official account mentioning Koog and building scalable and production-ready agents with Docker and Koog all together. And I really love their mention of, this metaphor of our name, like basically Koog is for cooking AI agents. And I really love this ratatouille cartoon mentioned here. It's really cute, right?
Yeah, because it plays nicely with the framework name, because the framework allows you to cook agents, so that's a nice pun. Yeah, and shall we tell about the vision a bit? What do you think?
Yes, of course. So I'll cover that. So Koog, in general, aims to cover the whole spectrum of AI development in Kotlin, not limited just to building AI agents, but moreover, it targets building AI applications in Kotlin. And I'm aware that some frameworks, from one hand, concentrate on specific paradigms, or even providing some basic components, just allowing you to connect to LLMs, connect to vector storages or any other RAG providers, and then build something by yourself. Some other frameworks, they play a different role. They provide you the perfect demo experience or the perfect onboarding experience. You can build something from scratch pretty easily by just taking the default agent, providing it with tools, and it's just working, which is fine. But it's not scalable enough, and it's not controllable enough for the real use case. There are some other frameworks as well. For example, some focus on one paradigm. For example, building agents in a form of graph workflows. And there are some other players in this market, like, for example, some frameworks concentrate on some specific algorithms that is just programmed, like planning, for example. Koog doesn't work like any of this. Koog aims to provide you the wide range of tools, starting from the basic connection to the LLM, followed by the out-of-the-box building blocks, the out-of-the-box agents that you can just use and run, and also allowing you to customize the agent, building a graph workflows, which can be pretty complex. And we are also planning to expand it further. So we are planning to allow you to build non-graph-based strategies for your agents. And also, we are providing something on top. Because we are working with our machine learning colleagues, we want to provide some more out-of-the-box solutions, including prompts, including techniques, and including approaches, which just stay in the framework. And that's the overall vision of what Koog is right now and what we plan Koog to be. So the reason for that is basically because we discovered that there is no silver bullet. We tried different products and we tried different approaches. And some approaches work for one scenario, but they fail in another scenario. So instead of just focusing on one paradigm, we want to empower the developers with all of the tools available so that you're flexible. So let's briefly cover some benefits of Koog once more. Andrei, I know that you are one of the biggest fan of DSL that I know. Could you tell me about it a bit more? Why do you like DSLs?
Yeah, absolutely. I love DSLs because DSLs let you create a new language without needing to create a new language. And they let you create a specific domain-specific language that is tailored exactly to the task at hand. And with Koog, you get exactly that, a set of APIs and shortcuts that are tailored exactly to the AI workflows development. And yeah, that's pretty cool. Shall you tell me more about the real product development?
Yeah, sure. So another strong thing of what Koog is basically Koog is powering the real product development inside JetBrains. Why is it important? Recently, I remember watching some series in Talking Kotlin YouTube channel. It was an episode with Rod Johnson. Who doesn't know, he is the creator of Spring framework, which is obviously one of the most well-known frameworks for JVM. And once he was asked what led to this huge success of Spring, one of the core reasons that he mentioned was that none of their team was really a framework developers. They were not building frameworks for the sake of frameworks because it's fun experience. No, they were all practitioners. That's what was important. They were all working for real companies, doing real jobs, and building real production-ready microservices. And they gained a lot of experience. And once working on that, they started to pack and project this experience to the form of a framework, which became popular and useful. And I believe that's exactly what's happening with Koog right now, because we are building a lot of agents inside JetBrains. We are doing a lot of experiments and products. And once gaining this experience and gaining some experience with that, we try different approaches, and only whatever works remains in the framework. And that leads us to the next part, which is what we call high-level solutions. I don't really know any better word for that, but let me elaborate. So by these high-level solutions, I mean that we try different techniques together with our products and machine learners and researchers. And whatever works remains in the framework. That includes not only the basic building blocks, but also prompts, approaches, techniques, and algorithms, so that we want our users, not including internal users in JetBrains and external community, the open source community, to be able not to focus on experiments. You don't have to be experimenter. You can be a practitioner, a builder. You can focus on building your real products and providing real value. And our colleagues, including ourselves, we can focus on doing these experiments for you. So that's like the goal for this.
Yeah, and actually with I guess I can tell a bit more about multi-platform, because as much as I love DSLs, I also love Kotlin multi-platform. So, and with the power of Kotlin multi-platform and with Koog, you can actually develop AI solutions not only for JVM and for server side, but you can also bring those solutions to the end user devices, such as browsers, iOS devices, Android devices, and soon more features coming in the future. And actually, Koog is the first AI framework with the native deep IDE integration as well, because we are actively working on extensive IDE support, such as AI debugger and advanced code analysis, and we're greatly invested into this. So this, in my opinion, is also one of the serious benefits of Koog.
Yeah, let me put like a little bit of disclaimer here. So actually, it's still in progress, and pretty soon we're gonna publish something like really cool. So stay tuned. It's not yet like ready to be like tried, but we believe that that's like actually like very important to be able to build agents with the IDE supporting you, not like without, right? And the last but not least, is Koog allows you to build something flexible and predictable in the form of building specific steps in the workflow and making sure that only whatever you programmed actually is what is happening in your system. So instead of like building these random guessers somewhere, Koog allows you to build the actual systems that you can trust. And that's like the part of the Koog benefits, but there is also a huge part that is basically gifted to the Koog by Kotlin as a language. And the first one is basically the access to the enterprise. So unlike many like other languages, Kotlin is positioned actually perfectly for AI, because it allows you to reuse the existing infrastructure and data pipelines that exist in your JVM enterprise level applications and integrate that into your agents. You don't have to build something from scratch, something like teeny tiny startups. That's not about that. You can use your existing code and existing users and existing applications to build something with AI. And Kotlin is great for that. But again, Andrei, it's like your turn to include something about DSLs.
Yeah, sure. And more than that, more than JVM support, Kotlin also gives us type safety. And type safety is important to protect us from making silly mistakes. So we get these nice and stable workflows. And we can also share this code with our ML researchers, and they would be able to read, understand, and help you without having to know any of the JVM languages beforehand. So that's really cool also.
Yeah, I can only confirm, because that's what actually happened even in our team when we were doing some AI development, and we once we showed our code in Koog to our researcher colleagues, they actually managed to easily understand it and pop up into the development. And another important thing is basically the access to multi-platform. Kotlin doesn't stop where Java does. Kotlin allows you to write the solutions, and with Koog you can write AI solutions, not only for JVM servers, for example, but also for mobile devices and embedded devices, right? So that's it for the benefits of Koog parts. I hope it wasn't that boring. And now we can move to more technical and aspects, and we're going to start with some theory. So let's talk about some Koog architecture. What do I mean by that? I mean the architecture of the agent. So in our vision, agent has three components. The first of them is the environment. It's any application of yours. The second component is the agent logic, the brain, the strategy, how it works. And the third one is the connection to one or many large language models, many LLMs. And with Koog, you can, by the way, build not only agents that work solely with one LLM, but you can build more complex agents that delegate different tasks to different large language models. So how it works? The user will just see it as a black box. They will provide the input and get the final result from the agent. But under the hood, agent will communicate with LLM. It will send LLM requests, and it will get back the responses, which can be one of the two things. Always. It's either assistant messages, just like plain text, or it's a tool calls. And if LLM provides you with a tool call, the agent logic will delegate it to the environment. It will call a tool and get the tool result. That's how it works. And inside the agent, there is the strategy part. It's something that you can use out of the box. You don't have to think about that. Koog already provides you the working strategies, but Koog also allows you to implement something very custom for your specific application. Let me show you some examples. Oh, sorry.
Yeah,
Let me fix my mic. 1 second. Here it is. So let's write the picture on the left with the code. So you will just write AI agent, and then you will need to connect it to your application. For example, you are building some search and email integrations. So you probably have some search function in your code, and you bind it to the tool registry. You register this tool, and you also register the sending email tool from your app or from your environment. Then you provide the agent strategy that you can implement by yourself, or you can omit this parameter because Koog already knows some strategies out of the box. And then you provide the agent config, which is basically the prompt, the task for the agent, what it should be doing. It's also the connection to specific model and some other parameters like max agent iterations and something else. And finally, the last part is actual connections to LLMs. For example, here I'm connecting to OpenAI. So that's a bit abstract. Let me show you some concrete and simple example. The simplest agent. Let's imagine you are building a banking agent that will automate some banking operations. So what you will do, you will just provide some banking tools from your existing code. You will provide a task like you're a banking assistant. You'll provide a model like GPT-4o, and you will connect to OpenAI. That's it. 1, 2, 3, 4 lines of code. That's going to be working.
Yeah, and I guess we can highlight that there is no strategy here, because as Vadim mentioned previously, there is also pretty good working default strategy that you can use out of the box, so you don't have to define it by hand.
Yeah, for sure. So let me now elaborate a little bit about the tools. So what are tools? Tools are actually any functions in your existing code. For example, in a banking application, you can have something like this, like function send money. How to make it a tool for Koog? Just call it a tool, and that's it. Of course, that will work, but to make it working better, you need to explain to the LLM what the tool is doing. And you can bring this parallel to explaining to your colleague from the development team, what is the meaning of this function. You will document, you will explain the meaning of the function and the meaning of each parameter. And that's exactly what you should also do for the LLM, so that it can understand the meaning. So for this, we provide the LLM description parameter, which allows you to provide some explanation for the LLM, and that's it. And now the final part is about agent strategy. What is agent strategy? So basically, as I mentioned, Koog allows you, or in the very nearest future, it will allow you to build different types of strategies But right now, the paradigm that is working great is a graph paradigm. So Koog allows you to build strategy graphs. So what are actually strategy graphs? Basically, a graph of your agent consists of different nodes, where a node is just a normal Kotlin function. It has some input, and it has some output, and it explains how to transform the input into the output. As simple as that. You can think of nodes as just like functions. And then, depending on the outputs, you can build some conditions, or like many of them. So if condition 1 is true, the agent orchestration logic will go from the node A to a node B. But if the condition 2 is true, it will go to the node C. And also, the cycles are allowed. So this allows you to build multiple different state machines that will control the agent logic. It actually explains to the agent how it should behave with LLM and with the environment. Let me bring some more concrete examples. Requesting LLM is actually a node. It takes a string, the user message, and it produces the message from the LLM, which can be, as we mentioned before, either a system message or a tool call. Then executing a tool is also a node. It takes any tool call and it produces a tool result. Pretty obvious, right? And sending the tool result is also a node. It takes the tool result and produces a message which is, again, either a system message or a tool call. So basically, you can think of these components as a Lego game components, or like you're playing with a puzzle game and you have to compose one puzzle after each other, and only the ones that are compatible can be put together. Just look at these 3 components, like these 3 Lego bricks. You can imagine how you would build something like that. This is basically the default out-of-the-box strategy that works and powers the simplest agents. You start your agent, you request the LLM. If it's a tool call, you start executing the tool, or otherwise, you finish your agent. After the tool execution, you are sending the tool result back to the LLM, and then you loop again through the same logic. That's it. And you may wonder, do you have to manage the state of the LLM, the history, the messages that have been sent before? And the answer is no. When developing Koog applications, you can think of this analogy. Imagine that you are just a user and you are chatting with ChatGPT. You have the ChatGPT window in your browser, and the window remembers the conversation history. As a user, you only care about the last response, and after reading that, you think about what to ask next, and you're giving the next question to the LLM. And the window is taking care of managing the history. As a user, you don't have to close the window, open another one, and copy up the whole conversation. That happens automatically, right? And that's the same for Koog. So basically, Koog, as a framework, takes care of all that logic and allows you to think in a typed way, in a type-safe way, of the previous steps and the next steps, and how to compose one after each other. So here is basically the link to our GitHub. Please, if you're interested, please check it out. And we're going to move to the live coding part. Andrei, I guess it's your turn.
Yeah, and I guess we can also mention that we mentioned some strategies today, and we won't be looking that detailed. We won't be taking that much of a detailed look into the strategies and how they implement it. You can join the next live stream where we'll be actually disassembling those strategies and implementing our own strategies to understand the whole concept of the graph strategy well. But today, just to demonstrate, just to give you an introduction to the Koog framework and what you can do with it, I'll suggest you to take a look at this simple assistant that can access the web and can help you automate various web-related tasks. For example, if you want to do some market or competitor research, and we can actually implement this simple agent with Koog. So let me walk you through the code, and then we will also play with it a bit and see that it actually works. And first of all, of course, we need some web access. And for web access, I'm using pre-made APIs. I'm actually using Bright Data here, but you can use other companies that provide similar functionalities. So the code is pretty straightforward. First, we define some DTOs that are basically API schemas that we will get as a response from the Bright Data. And we will be using two tools. We will be using a search tool that is a Google search, and we will be using a page scraping tool that is basically read the page, drop all the HTML text, all the JavaScript, and leave only the content. So we are defining basically response schemas here. And the more interesting part is how the whole web access logic is implemented. So here we have a simple class that takes an API key and a cater client. I'm using making just simple REST requests, no SDKs involved. And we have two tools. And as mentioned previously, tools are just the functions. So we have a function. It's a regular Kotlin suspend function. It's called search. And it takes query as a parameter because we want to search for a certain query, for example, pizza. And it's basically, just like 10, 20 lines of code. We're making an API request and getting a response back. And we have the next tool, that is a page scrape tool. It's very similar. The only difference it calls a different API. But the logic is pretty similar. Just provide a URL to the tool and expect some page data in a nice markdown format that is easily digestible by LLMs, just what we need. But to make those functions actual tools, we also need to mark them in a specific way. And we can use a tool annotation for that. But if we want better results, if we wanted to explain to the LLM what exactly this tool does, it's also a good idea to put LLM descriptions here as well. So here we are putting an LLM description for the tool, describing like in a few sentences what this tool does. So search for the query on Google. And we can also describe all the parameters as well. So this, for example, is the query to search. And we're doing the same. We're doing the same for the scrape tool. That is, again, just a simple function marked in a specific way. And we can actually see that those are regular functions, and those are not some hard magical entities. Let's call them. Let's call them directly and see what they return. So as you can see, I have a main function here. I just get in my API key from the environment and creating the instance of web search tools class. And for example, let me call web search tools search Koog framework. So the same as I would just open google.com and type Koog framework. Let me run this, and we should see some result. And as you can see, we get an object as a response, and we can actually make it more human readable if the format is as a JSON. So we can use encode to string, and then like this, and we can rerun this sample, the same code, and we get a more human readable output. So basically, that's what those tools do. They return us some Google search results. Yeah, perfect. And for example, if we have some link here, let me copy this link. We can also use scrape tool. It's called scrape to sort of read this web page, drop all unnecessary markup text, whatever, and just get in the page data itself. Yeah. And as you can see, we're getting some JSON as a response. That is basically that contains some markdown, which is in content of the Koog.ai page. Perfect. So as you can see, just regular functions, nothing magical. And we can use those functions in our agents because we don't want to call those functions ourselves. We want to let LLMs decide how to call those functions and when to call those functions. And to do that, you need to, as I mentioned before, first, actually, you need to extend the class, the web search tools class from the specific toolset class. It's just a marker interface. Then you need to mark all the functions that you want to be exposed as a tools to your LLM with the tool annotation and provide some descriptions. We already did this, so we can move on to the agent configuration. And I have here some configuration. Let me uncomment this part. And what do we need to do here? First, of course, we need to get our API keys. In this case, we're using OpenAI LLM, and we're also using the private data. So I'm getting my LLM keys. Then the same as before, I'm just instantiating my web search tools class. And now I need to instantiate a specific entity called tool registry. So what tool registry is, basically, it's a collection of tools that will be exposed to our AI agent and to the LLM. And with each request to the LLM, we will send those tools descriptions so that LLM knows which tools are available and can call them if the LLM decides to do so. So because we extended our web search tools class from the toolset interface, we can just use tools function, tools builder function, and just pass this instance here. That's it. That's how we create a tool registry. Now we need to create an agent config. And what agent config does, of course, we want our agent to have some presets, some values, and some settings. The most important probably is the prompt itself, because we want to tell the LLM what this agent does and what this LLM needs to do. So here I'm just using some simple string, like you're a helpful assistant that helps user to research information on the web. But of course, in the real world scenarios, you would probably expand on it, provide maybe more examples and stuff like this. And here we also specify the initial model that will be used. In our case, we're using just GPT-4o. And max agent iterations. This is needed to protect us from agent going in the loop indefinitely, because it can happen. It can happen if, for example, implementing graphs, implementing strategies can be hard. And of course, everyone makes mistakes, and we don't want to spend too much credits and spend too much time and compute. That's why you can limit, you can set a maximum limit to the agent iterations. And I'm just setting it to like some semi-random number, like 50. That should be enough in my estimate. And the last part to finally get this agent instance that we can actually run, we are instantiating the agent itself. So our agent, you can specify input and output types here. And since we're using this strategy, by the way, I'm putting this strategy here explicitly just to make it more visible, that we're using some default strategy. But again, as mentioned previously, you don't have to specify it explicitly, because in fact, this is the default strategy. And what this strategy does, it's basically a tool calling loop. So you provide an input to the agent, you provide a set of tools to the agent, and it would run, it would query LLM, it would execute some tools until it decides that it's done executing tools and would and return some result. And this simple strategy, it's string, because it's a default strategy. We just like with a regular chat, just like with a regular, for example, ChatGPT window. Normally, you provide some string as an input and get some string as an output. Of course, there is now also multimodal support, but in simple case, it's just that string in, string out. And we are providing our prompt executor, the connector to the LLM that we will be using to call LLM itself, and providing API key here as well. Then the strategy, then the tool registry, so the collection of tools that will be exposed to our agent, and the agent config. So basically here, it's a final step. We have to piece all those configurations together: prompt executor, strategy, tool registry, and agent config, to get this ready to go instance of the agent. And then we can, that's it. That's already an AI agent, and you can call it, you can work with it. And to do this, you simply call agent.run and provide some input. So in this case, the input is string. So we are providing a string query. And because the output is also a string, we will get a string output. And I can specify it here explicitly. So as you can see, string in, string out, and we are just printing some result. And to get more observability, to see that the agent can actually call our tools that we provided, we can use this nice handle events DSL that allows us to specify different event listeners, and for example, to print stuff to the console or write some logs, etc., etc. And in this case, I'm using on tool call listener, and you can see that there's like more listeners. For example, you can do some action after each node or after each LLM call, but in this case, we're only interested to see which tools and when our LLM calls. So I'm using this handler, and I will be printing this to the console each time the LLM calls the tool. And let me actually run this and see if it works. And the query is, I'm asking the agent to tell me about the Koog framework. So I'm running this, and we should see some logs in the outputs. And those are the logs of the strategy. We can see like that some nodes are being executed, and that the agent works. And yeah, so here we can see that the tool was called, the tool called search, and the parameters. Yeah, and we can see the parameters. So the agent decided to call the web search tool with the Koog framework as a parameter, and then it decided like, okay, yeah, that's probably enough, and it provided me a description of what the Koog framework is. The Koog framework is a Kotlin-based platform, blah blah blah. And here is basically like, here is the output of our agent. But that's pretty short. And for example, I want a more detailed explanation. So let's try to ask for it. Tell me in details about the Koog framework, and let's see how modifying the input, how modifying the query affects the agent execution. So I'm just rerunning the same agent, and we can again see the output. And this time, as you can see, it called tool search first, because that's something logical. The agent just wants to search what the Koog framework is. But then, oh, it finished. So then it decided to, let me search, tool call, yeah. But then it decided to call the tool named Scrape and provided the URL to the Koog website to get more information, to actually read the website, analyze it, and provide a detailed explanation. And that's what the agent did. As we can see, this time we get more detailed explanation, and I can actually, it's kind of long. It's kind of long, and I can copy it probably to a separate file, and we can check the output. So yeah, this is what the agent told us after doing some research. This is as I mentioned, this is kind of a simple agent because at this stage we don't want to make it too complex. We're just using a built-in strategy that is, as I mentioned previously, just a loop. But even at this stage, you can do a number of experiments because you can use the power of prompt engineering. You can craft here some smart prompt explaining the LLM what these steps are and which sites it should check, which queries it should run. But of course, there are certain limitations to this approach. You cannot, because prompt engineering, it's kind of unpredictable, to be honest. And that's why we provide you with the ability to specify a custom strategy, which we're going to take a look more closely at the next stream. Yeah, and Vadim, do you want me to pay attention to like specific parts? Do you have something to add?
Yeah, thanks, Andrei. It was like really awesome, and it looks like really cool. So basically, even with some such like small agents, you can already do some like real stuff, like searching for something, or even doing some analysis using the web search. And I would add up here that basically one of the beauty of this is that if you would use like just LLMs for answering the questions, it would first of all be more prone to hallucinate, and second of all, it will be limited in terms of context. So basically, most of the LLMs were trained on the past data, and specifically this Koog example, Koog was released like two and a half months ago, and I bet most of the LLMs still don't know what it is. And basically providing this like precise web search empowers LLM with much more capabilities. So yeah, thank you so much, Andrei. And should I also share my screen and show something funny? Just a second. Screen.
I guess that's still my screen. Probably you want to tell us something more about the strategies. Yeah.
Yes. So I'm gonna just briefly introduce you to the idea of strategies. I was scrolling through the questions while Andrei was doing his first part of the talk, and indeed there was a question like what strategy is. So apart from all the pictures with graphs and built components that I mentioned, I would like to basically briefly show you that strategy is actually no magic here. So this is the basic agent setup. So you have AI agent, prompt executor, strategy, currently the simplest default one, or actually we have some other defaults like React strategy, which is basically different because it does some like thinking or reasoning step after each time or after a while of steps. And the default one just performs the basic loop iterations. And I will tell you how to build something precise, custom, and still like small and funny. And then we're going to build the out-of-the-box strategy, and I'll explain you how it works. So this is the basic agent setup. And let me create some strategy, like my strategy. So I create a strategy using this strategy DSL builder. And for the strategy, as well as for the node or for the agent, I have to specify its types. Of course, it can be automatically deduced from the context, but let me just precisely state that I'm going to be building a strategy that converts a string to, for example, an integer. pretty small thing. Of course, I have to specify the name of a strategy. I said it's my strategy, so the name will be my. And inside the strategy, I'm going to be creating a few nodes. So as I promised, the first thing that we're going to do will be like really something small. So let me create a node that will take a string and convert it to a integer, to int. Basically, it's a node. I'm really sorry, my IDE is a little bit slow right now. So I'm creating a node that takes a string and produces an integer, right? And basically, what it does, it just uses the it.toInt. As simple as that. And let me also create some other node, like increment.
But I believe you have to use by instead of equal sign for the nodes, because you want to get this nice ability to deduce node names from the variable names.
Yeah, thanks, Andrei. Nice catch. That's indeed one of the powers of the Kotlin DSL. So, of course, you can provide different names for the nodes, which are essentially the steps in your agentic algorithm, in your agentic strategy, and then to be able to like read them in the telemetry logs or elsewhere, you will need the names like toInt. But with Kotlin, you don't have to do that, because the by delegating operator allows you to basically get the name from the name of the variable. So that setup would work. And the same with like the increments. So increment is a node which, yeah, thanks IntelliJ. I don't need the rest. Increment just takes an integer and returns the next number. That's it. And now let me connect everything. So I always have I will be building some edges, just like connections from one node to another. So from the node start, I will go, which obviously the node start always present in the strategy. So from the node start, I will go to forward to int. And then from toInt, let me just copy this line. From the toInt, I'll be forwarded to increment. And then finally, I will forward from the increment node to node finish. So obviously, what the strategy is doing here, by the way, it's not doing anything with LLM. It's just doing some like random, code operation. So basically, it just takes a string, parses it, and after parsing, it produces the next integer. So to such agent, you can actually pass some like string parameter like 100, and you can then run this agent, and it will output the 101. So as simple as that, and of course, yeah, you have to like provide the strategy here, my strategy. As simple as that, and everything is type safe. For example, if I would change the type of a strategy here, first of all, these two nodes will not be compatible, because toInt expects a string input, but the start node provides the integer output, which is incorrect. At the same time, the agent run function will expect you to provide an integer, and I'm providing a string. So this code will not compile. That's exactly what we mentioned when talking about the DSL capabilities of Kotlin, and why it's exactly great for agentic development. And right now, from this like small and funny example, you can basically like run it by yourself in your spare time. Let me show you something more complex. Specifically, we're going to be building this out-of-the-box default strategy. This is the graph that you have already seen on the pictures, and that's exactly the strategy that Andrei was showing in his example. So basically, let me just define the 3 nodes that are required. The let's call it ask LLM, by node LLM request. I'm sorry for the slowness of my IDE. I don't need the name. Then I'm gonna need the node like call tool. It's basically calling any tool from your application provided to your agent. It's called, you don't have to implement it, although you can, but it's called node execute tool. And finally, you will need the node to provide the tool result back to the LLM. Provide, or like send result. Let's call it send result. That's it. And now let me basically draw some edges. From the node start, I will go to asking LLM. So whatever, you always start with asking LLM what to do, and then the LLM will decide what will be the next step. Let me again copy this line. And here the interesting part begins. Is it frozen? Sorry.
Yeah, sure, no worries. I guess in the meantime, I can elaborate a bit on what these node start and node end actually do, because as you can see, we don't define them anywhere. And those are special nodes, because as any graph has some input and has some output. So node start is basically a special node that will emit an input to our strategy, that will emit the thing that you supply in the run as an argument. So if, for example, the strategy is taken string, then node start will emit a string. And if it's taken int, it will emit int, and so on and so forth. And basically the same with node finish, but in reverse, because node finish, it does not emit the value, it consumes the final value of the agentic execution. So what you put as an argument to the run is what will be emitted by the node start, and what you put as the final result to your node finish is what will be returned from the agent.run. So those are kind of special nodes that allow us to actually consume and return results and responses.
Yeah, thanks, Andrei, and sorry for this delay. It was some issue with my screen sharing. I just had to reshare the screen. So basically what Andrei has been explaining, let me do in my IDE. I'm going to just specify type explicitly. Usually you don't have to do that, and we are actively planning to provide you some great tooling, but just for the educational purposes, let me show you the types of the nodes. And basically, this will explain why the IDE doesn't like the part here. So askLLM cannot go to tool calling, because the askLLM produces the response, which is a message.response. And the call tool node expects you to provide the tool call, which is a type that inherits the message response. So basically, if you resolve to the definition here, you will see that it's a sealed interface. Response from the LLM can be either a system message or the tool call. That's exactly what we have been showing on the presentation pictures. So how to make it compatible, how to connect this to Node? Yeah, the IDE already provides me the correct answer, but let me elaborate a little bit. So in the default or non-out-of-the-box scenario, you will have to write some condition. So there is a DSL method on condition. It is, and let me copy the whole type name. It's that one. If it's a tool call, I will go to calling a tool. And still a problem, because I just checked the condition. I don't transform the value. So there is a DSL method for that. I can write transformed it as message tool call. Pretty long line, right? Of course, you don't have to usually do that because there is a better syntactic sugar on top of this, because that's like a pretty popular use case to check the type. So there is a DSL method that is called on is instance and the class. That's it. Pretty nice, but still not so convenient, because among many other types that can be there inside your strategy, depending on your application, message tool call check is very much important. At the end of the day, this is like one of the most needed checks. And of course, there is the DSL even more syntactic sugar on top of that one in the framework. So you can write something like on tool call, and inside even you can specify a lambda. For example, you don't want to go to this node for all tool calls, but only for the ones that have, I don't know, a specific name of a tool. But usually, or in this example at least, you are doing some generic strategy, not the tailored one, so it will be just true. So on any tool call, you will go after asking LLM, you will be going to calling the tool. But otherwise, if ask LLM provides you not the tool call, but the other one, the assistant message, let's say that we're gonna just finish. Node, finish. And again, there is a similar sibling method, which is called onAssistantMessage, and also true. So this one will check the type. And yeah, thank you, the type checking system. Remember, initially I was doing a string to integer strategy. So the node finish, let me just control navigate to it. It has the type of the output of the strategy, which is integer. And I'm providing the assistant message converted to a string. So let me change that. Again, this is how basically Kotlin saves me from doing these like silly mistakes. So from asking LLM, I either branch to calling the tool, or I go to the finishing of the whole strategy. And I do then after calling the tool, that's pretty straightforward thing. Let me just put it at the bottom. From calling tool, I forward to sending tool results back to the LLM. And they are already compatible, because it provides the tool result and it receives the tool result. And finally, the sending result is like a hanging node. If I run this code, it will just throw an exception that there is no way to go from this node to finish. So I have to also basically copy this part. Let me. Why my PC is freezing again? Sorry, I have to reshare the screen one more time.
Yeah, sure. Like in the meantime, I can also elaborate a bit on the default strategy, because what Vadim implements here is pretty much the default strategy. Like the only exception here is that the default strategy also has some additional configuration parameters. But in the most simple case, the default strategy, it's just that. It's just some trap that has a tool calling loop. And in case of assistant message, it just terminates the graph, the strategy, and returns the final assistant message. Yeah.
Yeah. Thanks, Andrei. And I'm live again. So similar to asking the LLM, the ask LLM produces the message response, which is basically the same thing that happens with sending result, because again, you're just sending another piece of information to the LLM, and then you have to branch again from sending result, you go to calling the tools, or you go to the node finish. And that actually it's, if you check the code of the default out-of-the-box strategy, that's exactly how it's working. And now you know how to implement a similar stuff by yourself. Of course, I mentioned before when giving this ChatGPT analogy that there is also something like a context available inside each node. Let me just briefly show you the idea of how it works. And then we basically would finish this session and go straight to the Q&A. So let me just implement some like my node by node I don't care about the types. Let it be like unit to unit. And let's imagine that I need to make a node that doesn't add anything to the history, but just calls the LLM. So inside the node, I mentioned that it's basically a function from this input type to this output type. But that's not exactly true. There is also the receiver type available out there. And I'm really sorry. Again, my ID is, no, it's actually my machine. Yeah, so now it's unfrozen. So inside, if you write like this, there is a bunch of things available. So there is a configuration, environment, LLM, and many other things. Strategy name, agent ID, many different things available. So among many different objects, LLM1 is one of the most important. So inside the node, you will see the LLM object, which contains the tools that are bound to your LLM. You have the prompt, which basically, among different things, contains the list of messages, basically the whole history. And it also has like different other tweaks and parameters. It's being frozen again, so let me just continue the description. So yeah, basically, the concept is that all this context, including the list of messages, gets updated every time you execute the node. So you only care about the input and the output, but you also have the access to the whole thing. You can also modify and exchange, just request the LLM without changing anything. Let me, does it work? Yeah, okay. I found a way to unfreeze my screen. So you can basically do something like LLM, and I will have to, unfortunately, acquire a write session, because LLM essentially is just the object which is shared. And in one of the future sessions, you will learn that there are parallel nodes available and concurrent execution with coroutines. But in general, LLM is a shared object, and it has a mutable state. So you have to acquire a write session to basically modify anything. And then inside, you can, for example, request the LLM. So the request LLM is basically a function that will give you the message.response. And let's say that I want to just request the LLM with exact state that I have, response. I will save it in the response variable. And then I want to, for example, update the prompt. I can say like prompt now equals the older prompt, copy messages, and the new list of messages. That's going to be too long. So there is a DSL method for that. I just write update prompt, and inside I can see that now we have the assistant message from the LLM with the response dot content. For example, that can be an option. So this node will not populate any input. It will not add anything as a user input to the history before doing the request. It will just request the LLM with, again, existing thing and add up the assistant message at the end, regardless of the type, by the way, because even if it was like a tool call, I just take the content, the string, and say that it's always the assistant message. So this node is pretty useless, but you can do that. So in the next sessions, we're going to learn much more and deep dive much more into many of these details. But for now, I just wanted you to have the basic idea of how strategies work and how strategies might allow you to control the way you operate with LLMs. So far, I'm going to stop sharing this part of the screen, and I'm going to share the final slide from my presentation, and we can go straight to the Q&A. Yeah. All right. So Yeah, the first question that I see is, and yeah, by the way, thank you everyone for your warm comments about how Koog is great. We are really always happy when people say that Koog is great.
Yeah, thank you very much. Thank you very much.
Yeah, so the first one, is there KMP support? Yes, there is. So Koog supports the platforms that were mentioned are JVM, JS, WebAssembly, and in the nearest release that's going to be happen like really soon in a 1 or maybe 1.5 weeks, we're going to have the iOS support, and we are looking towards other targets.
Yeah, I already have the PR adding iOS support. Again, thanks to the awesome community that also submits their own works, helping develop the Koog. So yeah, stay tuned for iOS.
The next one, is Koog free or is there a subscription plan? Andrei, do you usually pay for Kooging?
No, I'm doing it for free because it's just a library. You can download it and you are free to use it. So yeah.
Yeah, basically, if you scan this QR code, it's leading to the GitHub page, and it's open source. So you can not only just use Koog, but you can change Koog, copy Koog, and use it in your own proprietary code. So there
Yeah,
is
that's
not
actually what some people already do. As I mentioned, we get lots of other contributions, not only from our own team or from internal people at JetBrains, but also lots of external contributors from the awesome community. So yeah, that's really cool.
Does Koog store context across sessions? I think part of it I have already covered. So basically, Koog stores the context over time, and it stores the history, which is always increasing. If we want to preserve the context over the sessions with the user, or moreover, if, for example, at some point the agent crashes in the middle and you want to restore from the same place, there is a feature called persistency. And I think in the next, or maybe one of the next sessions, we're going to be making some smarter and also fault-tolerant agent that implements that. But also, please feel free to visit our docs. They are available from our GitHub through the link, and check it out. So yeah, I'm just like skipping some questions that have been, I think, already answered. Is there any setup needed to make the platform, example, banking applications be used in the example given? I'm not sure which example you mean, but I would assume the one in the presentation, right? So the only setup that you need is you have to add the Koog dependency we published to Maven Central. You have like a few options. We have per module dependency, like as you would probably see in many other libraries for different Koog components. But also you have the all-in-one dependency, just Koog-agents, and then the version. You just add it to your Gradle or Maven config, and then you can use Koog as any other library like coroutines. No specific setup is needed, apart from, of course, connection to the LLM. So you have to either have the token for OpenAI or Anthropic or Gemini or DeepSeek or whatever else, or you will have to like self-host, for example, Olama somewhere on your backend or local machine. But
Yeah.
otherwise, yeah.
Yeah, I just want to, sorry for interrupting. I just want to add it to the examples, to the question about examples. We also have a dedicated examples module in our repo, and lots of examples here. Well, actually, all examples here are pretty much standalone. So you can just take any example, put your own API key and run it. We try to put as much examples as we can to cover different aspects of Koog here. So this might also be an option to get yourself familiar with Koog and with various aspects of Koog, with various capabilities of Koog.
Yeah. Going to the next question. Yeah, I actually like this one about the examples. How can I do, for example, if I have an agent into the Android app and I want to transform the agent answer into a nice UI? For example, show the agent answer inside a nice card or something fancy.
Yeah, I guess I can answer that if you don't mind, because
Sure.
yeah, we have again, if you check examples module in our repo, we have a demo Android application example. That is a separate. It's like a standalone Android project that you can open in Android Studio or IntelliJ IDEA, and there you have a example of how you can integrate Koog into existing or into new Android applications. But I guess like the part about transforming the answer into a nice UI, it's kind of out of scope, because with Koog you can get the content of the response, the text, and you can use structured output to get the structured result that can be parsed into classes, not just some string. But and yeah, and then with the structured result, with the structured output, you can draw your own fancy UI, or you can use, for example, Juni to draw this UI. By the way, if you check this demo Android application, it was written with the help of Juni, and Juni is actually kind of really good at drawing compose UIs. So this might also be an option, but it's not something that Koog directly addresses.
Yeah, thanks, Andre, and definitely please feel free to check out our Android application example. I would probably just add up a few ideas here and a few important things to mention. One of the things is that if Koog agent or any AI agent in general decides to call a tool which is critical, specifically, for example, if you're doing like banking app, and the user has to like confirm that the operation is valid, you have to basically you have a few options. One of the options is you can include this logic into the event handler. Like Andrei has been showing, you can handle events by just printing the output or the fact that the tool has been called. But you can also like send some messages, because it's a suspend function. You can send a message to coroutine channel and then await until the user says, yes, I agree with this action. Or otherwise, no one prevents you from writing any code inside a tool. So basically, you can show a message as a part of a tool call. So tool calls are also suspend functions, and they can include some UI. Another funny idea that I learned like quite recently was that basically you can think of some personalization, UI personalization using AI agents, because basically you can describe UI, or at least some basic parts of UI, as JSONs, and LLM is great in generation of these JSONs, which is basically exactly the tool calling. So when given all the context about the user and the current situation and the workflow, you can allow the LLM to basically show different types of windows and buttons and messages, so that you can build up the very much personal UI for each user. Just as another like crazy idea to consider.
Yeah, that actually sounds really interesting, and we would be really happy if someone does this and submits a PR adding something like this into our examples. That would be really awesome.
Yeah, the next one I think mostly goes to Andrei.
Yeah, do you have a link to the code that you show us? I guess I'll upload this web search agent to the examples module, sure, so that everyone can see it, can run it, and play with it. Yeah, it's not available yet, but I'll do this like I guess today or in a few days, and yeah, and stay tuned.
Mm-hmm. Thanks. The next one I actually want to answer because it looks interesting, but Andrei, do you have an idea of what is meant by handoffs here?
Actually, I have no idea, and I wanted to ask you. Maybe you know what a handoff is.
Yeah, unfortunately, me neither. So maybe if someone could provide some more context in the comments, we'll be really happy to answer this one. Yeah, the next one, can we output to Markdown using a helper class? Is any such helper available? So yes, we have a few options. So one of the options is structured output, but it currently supports only JSON format. So you can basically, it's actually a part of a strategy in the agent. So you can force the agent to output something in a specific format. And there is another thing which is available specifically for Markdown output. It's a streaming, because we figured out while working on agents in JetBrains that Markdown works like really well for streaming uniform types of information many times. So you can ask the LM to like stream some output, and then you can like parse it and even call tools from it. And there is a streaming Markdown DSL for that. So please feel free to check it out in our docs, or otherwise, I believe we're going to be covering it soon in our live stream series. So
yeah, Vadim, do we have any other questions? Because I guess we're running a bit out of time. So maybe like one last question that you think might be interesting, and we will wrap up.
Yeah, there is like actually so many questions in the chat. I haven't even reached like the middle, just like while scrolling through them.
Yeah, I guess if you really want your questions to be answered, like you can always create a new discussions on GitHub repo. You can join our Koog channel in Kotlin Slack. So yeah, we're usually trying to stay pretty active here and trying to answer all the questions from the community. So yeah, feel free to reach us out here as well.
Yeah, thanks, Andrei, for mentioning that. Definitely, we invite you to join our official Slack channel in the Kotlin Slack, where we basically do all the support, or feel free to open an issue on the GitHub or open up any discussion. This question actually sounds like interesting because let me read it out again. Can you adjust the tools available to the agent during the agent iterations? For example, if agent calls tool A, then we also give the agent tool B after. So currently, because of, out of the box, because of the way the LLMs work, it's not really available. But by building a custom strategy, you can basically implement exactly this logic. So when I was like showing this demonstration of how to change the LLM object or whatever is currently represented in the agent state from the inside of a node, you can actually include this logic there. So there is a tools parameter, which is transformable from a write session, and you can assign it to something like new. You can assign it to like a new set of tools after something happened. Or moreover, I think, Andrei, maybe like you would like to also comment on the subgraph with task, which also can change the tools.
Yeah, that's it's maybe a bit different than the original question, but it's really powerful component of our framework, and we will be covering it during the next live stream. It allows you to basically run a dedicated subgraph with a dedicated set of only specific tools, not all the tools available, but you can limit the set of tools to only like specific tools that are needed for this particular task, get the output and pass it to the next subgraph, and then you can chain those components to get like the big graph, the overall strategy of your agent. So if you're like if your workflow involves multi-step processing or something similar, you should definitely check subgraph the task, because it provides already sane presets out of the box. Yeah, and we'll cover it during the next stream as well.
Yeah, thank you so much, and really sorry for not being able to answer like all of your questions, because there are like a lot of them, and also thank you folks for helping up us in the chat. So if you still have any questions or something unanswered, please feel free to join our Slack channel and ask us there directly. Or if you would like to have something more, like a next hands-on discussion, please also feel free to bring up this suggestion there. And also, please stay tuned for our next live streams. Thank you, everyone.
Yep. Bye-bye.